This is a modern oscilloscope, and you can see how we're deflecting. We have a beam that's going back and forth here. It starts at the left side, comes across. Now we can make that beam go faster, and if it goes fast enough, it looks like a blur. And if we have voltage we want to measure, we have to increase the time base until finally we can see it. If we start it where the voltage is at 0, we can see how it goes up and down and up. And you can see actually that there are little wrinkles in the voltage. And depending on what you're trying to measure, you might want to be just measuring that. If you have a very high voltage, then you change the total displacement here. All of this has to be very linear for a scientific instrument. One of the simple things that you can see here is this is really just a picture of the AC waveform coming out of the wall. And you can see all these little wrinkles are primarily due to other pieces of electronic equipment that are putting harmonics onto the waveform. And you could actually, this is a digital oscilloscope, so you can actually take the value of each of these little wrinkles and see what the time variation is from the start to where you get one of these, and also the amplitude of it. And then you can go back and see where in your system there's this, these bad harmonics are being added to the waveform. In previous modules, we talked about measuring voltage and current. But as people wanted to use electricity for more than just making motors move, but to communicate, they needed to be able to measure voltage that's time varying. And to that end, the oscilloscope was developed. The oscilloscope tube is made up of 3 major features. The first one is an electron gun on this end, and uses high voltage to accelerate electrons in a finely focused beam that hits this face. The second part is the face. It's covered with phosphor material. And the third part is a deflection system. So what we do is there's an amplifier that's made up at the time. These are from the 40s, 1940s, so it was a vacuum tube amplifier that would amplify both the voltage that you wanted to measure and also would generate a time base. The time base was a rising voltage, a straight line rising voltage, and when you put that across the back side, the deflection plates, then you would have the beam go across the side from side to side. So if you had a sine wave, it would go up and down as it's going across. The early amplifiers, as I said, were pretty much tube amplifiers, so they were limited in what they could actually faithfully reproduce. And at the same time, there was a need for very high voltage for the electron beam, and that was made up of a transformer and a high voltage rectifier, which would have been a tube-type rectifier. To make a measurement, you needed a calibrated time base so that you would know how fast the trace was going across the screen. And these controls on this side controlled the time base. And if you would also need to be able to calibrate and be able to measure voltages. Some voltages would be very high, some might be very low. So these knobs over here gave us the ability to measure very small voltages, and we'd amplify those And for very high voltages, we'd actually have to attenuate those voltages. And that would then give you an amount of deflection per volt. And you could then measure what's going on. The time base is made up by charging a capacitor with a known current source. That gives you a rising voltage that's right proportional with time. By changing the size of the capacitor, you get it to charge at different speeds. So a small capacitor gives you a fast time base. The sweep across the tube will be very fast. As the capacitors get larger, as you can see here, you can select with the switch which capacitor goes in. If you want to look at something that's happening slower, then one of these big capacitors is used to make a slow time base. The switch can vary from very, very fast speeds to very slow speeds.